Okay, so this experiment looks at how does the resistance, which is this column here, change depending on really the diameter increases, but the thing we're interested in terms of the variable is the cross-sectional area. Okay, and just at a quick glance at the results, we can see that as the area gets bigger here, as we go down this table, the resistance decreases. Okay, so we can already rule out the fact that they're directly proportional. So you should have done pi r squared. So you had to divide the diameter by 2 first of all to work out that column. You should have done v divided by I to work out this column. And from that then we can plot our results. We should get something that looks like a curve. I'll try and draw this on the screen. And a nice smooth curve through it. And what we can tell from that is when it's decreasing, what sort of relationship can we possibly have when it's decreasing? Doesn't touch either axes. We might look at inverse proportionality. And what you can do is you can read up at about 1 for our area and across to the resistance, and it's roughly 500. If we then double the area to 2 and read up and read across, so do this in your graph, you should see that that gets to about 250. So there's a good sign there that when we double one of those variables, so this is the area on this axis, the resistance on this axis halves. Okay. To make sure we could check again, we could try and go from, I don't know, 0.75 up to 1.5, and that relationship should hold true the whole time. So try that on your graphs. But a better way of proving inverse proportionality is if A is inversely proportional to R, that's one way of writing it. But another way of saying that would be A is directly proportional to 1 over R. So rather than saying A and R are inversely proportional, we can say A is directly proportional to 1 over R. And what we do in this final column is we calculate 1 divided by the resistance here. Okay, it gives us small values, makes it hard to plot, but you should then plot a graph of 1 over R, which will actually be in ohms to the -1 is how we probably write that, but don't worry too much about the unit there, and still area on this axis. And what you should see is, you'd use the ruler to do this, we get pretty much a straight line through the origin. So we can say that A, the cross-sectional area, is directly proportional to 1 over R, just another way of saying that the cross-sectional area is inversely proportional to R. Okay, so try drawing both those graphs and extracting that information from it.